we're discussing graphs. Let me share the screen with you guys. Here we go. So here it is. Okay, last time we were discussing how to find gradient and uh, in what case gradient is increasing and decreasing and positive or negative. We were discussing all that. Today, we will be discussing how do we find area under the graph and what is represented by area under the graph. Here we go. So let's consider this session as general things that we need to know about graphs. There is area under the graph. Now, no matter what is the shape of the graph, whether it is a straight line or an inclined line or a curve, whenever we are finding area under the graph, just 1 second. If this is a graph, what is meant by this term area under the graph? Look, this is the y-axis. So this is the quantity that is represented on y-axis. This is the quantity that is represented on x-axis. When somebody says area under the graph, what does that mean? What is the meaning of this phrase? Look, uh, some students think that graph means x-axis and y-axis. No, they are just the axis, and the area that they create, that is called Cartesian plane. What do we mean when we say graph? Remember, this line that shows the relationship between the quantities, this line is called graph. This is very important for you to understand. This is an important thing that you should understand, that when we say graph, what do we actually mean? And when we say area under the graph, what is meant by that? Look, there is an area trapped between the graph and the x-axis. This area is, what do we mean when we say area under the graph? So this is area under the graph. Yeah. And whatever the shape of the graph is, and whatever formula you use, whether you make it a triangle or a rectangle or a trapezium, you will always end up multiplying the quantity on y-axis with quantity on x-axis. Look, mm, if we divide this thing into a triangle like this and a rectangle, so we now have a triangle and a rectangle. Here, area will be 1 over 2 into base into height. And in this case, area will be equal to base into height as well. For example, if this is h1, this is h, then area of triangle will be 1 over 2 into base into height, and area of rectangle will be base into height. In both cases, I hope you can see that base is coming from the x-axis and height is coming from the y-axis, and we are multiplying them. So quantity represented by area equals to quantity on y multiplied by quantity on x. Let me give you some example for this thing. Let's say if we have a graph like this, okay, this is a graph, and this is actually axis, and there is graph like this. There is speed on y-axis and time on x-axis. So what will be the area of this particular graph? What will be represented by area of this graph? Answer
Distance?
is area. Yes, yes, because when we multiply speed with time, speed multiplied by time equals to distance. So area equals to distance. Similarly, let's say let's do a graph. Yeah. So this is a graph of voltage and current. This is voltage in volts and current in ampere. So what you think is the gradient of this graph? And what will be area? Now, in order to find gradient, you have to divide the quantity on y-axis with quantity on x-axis. So what do we get when we divide voltage with current? Let's recall, did we do any formula that has voltage and current together where they are dividing with one another? If you recall, you have done Ohm's law, V equals to IR. That tells you that over I equals to R. So gradient equals to resistance and area equals to power developed, because voltage multiplied by current is power. Or we use word dissipated. Now, let's do one more graph as an example. If we have restoring force on y-axis and extension on x-axis, and the graph is something like this. In this case, what will be the quantity of the gradient? And what will be the quantity of area? Let's discuss one by one. Mariam Imran. What do you think, Mariam? What do you think in this case? What will be the gradient of this graph?
I'm not sure, sir.
Okay, Naba?
So we have the formula F is equals to kx. And
Yes.
you would get the k, which is the displacement or change in the length.
No, K is something else. You have figured out the right quantity. You have figured out the right quantity. That is like you get full marks for that. But the problem is you don't know the name of that quantity.
Extension?
No, extension is x. F equals to kx. X stands for extension. Extension is on the x-axis right now. What is k? Soban Asif.
Yes, sir.
What do you think? What is k in the formula F equals to kx? If you recall Hooke's law, F equals to ke. K equals to F over E. So we have F over E going on over here. When we find gradient, we will be dividing F with a, so we will be having K. But what is K?
The constant.
It is spring
Spring constant.
constant. And what will be the area? Remember, extension is an example of distance traveled, distance covered. Any ideas? Anyone? What do we get if we multiply force with distance?
Work?
Yes. This will be work done on the spring or elastic potential energy stored in the spring, also known as strain energy. Okay, we will be doing these topics in the proceeding of this course, but right now in your head, I want to make this idea that whatever graph you're dealing with, you can always find out what will be the gradient of that graph and what will be the area of that graph. To find out the quantity of the gradient, you have to divide the quantity on y-axis with quantity on x-axis. In order to find the area or the quantity that is represented by area, you have to multiply the both quantities with one another. Okay? Now,
Yes, sir.
just 1 second. Okay. Now, one last thing about graphs, and this whole topic is done. Sometime we need to estimating. Sometime we need to estimate gradient or area. Estimating gradient or area. So why would we estimate? Why do we need to estimate something? Listen, problem is not all the time we get graphs that are very decent and very organized and very regular shape. geometrical figures. Sometimes we get graphs that are very different or curved graphs. Okay, just let's say we have two graphs here. One is curved graph like this, and another is curved graph like this. And in this case, examiner gives you a point, for example, this point P, and examiner wants to know the exact gradient at point P. How can we find gradient at a certain point?
Rise over run.
But we cannot do rise over run over here. It is a curved graph. If we
We'll
do
make a
rise over run,
tangent.
it will. Yes. Now you're talking.
And then use y2 minus y1 or x2 minus x1.
Then select 2 points on that tangent. Draw a tangent. Make sure you make the tangent right. So this is the tangent. It is a point that only touches the line at one point. It is a line that touches the curve at only one point. Like this. Now, what you need to do is, now you have to select any 2 points on the curve, on the tangent, like point number 1, point number 2. Draw a vertical line from the higher point. Draw a horizontal line from the lower point and complete a right angle triangle. And then use this rise and this run to find the gradient of this curve at this point. Mathematically, we can use derivatives and integrals to find areas and gradients, but the problem is that that is not part of our syllabus in physics. So we don't discuss them, but there are methods to find the exact area as well, but we are not doing them right now. Here is another thing. What if we have to find area under the graph? Now, how can we find area?
We'll make a tangent again.
No. Tangent is only for the gradient. Okay, there are multiple ways that we can solve this question. Number one is, this is for area. There are two ways we can do it. One is, we can split the whole graph into approximately equal sized trapeziums. Okay, we can divide the whole thing into equal size trapeziums, and then we can find their areas. And then we add all the areas to find the total area. Or what can we do is we can split it into a rectangle. Okay, we make a rectangle like this. Then we can make a small triangle like this. And then we can make another small triangle like this. Hello?
Yes, hello? Sir, we can hear you.
I hope you can hear me. Okay, good. I lost connection for some time. Okay, now we can split it into smaller shapes, and then we can find out the areas of each shape, and then we can add them. Like this. Why are you doing this again? Well, okay, and then we can add approximately this area and this area, and if it would be on a regular graph paper, you can always count the number of boxes there in this region, and you can count the number of boxes here. How many boxes are there? And then you can find out what is the area of one box, and then multiply the number. So this is another way, and one very effective and very shortcut method is that you do this. Approximately, what you do is you draw a line like this, and then like this. Now what you have done, see, if you find the area of this trapezium, the one that I drew with the black, if you find the area of this trapezium, you're actually doing two mistakes over here. You are ignoring this portion. How do you think this is compensated? This portion is added. And if you do a fair enough division of everything, you can have a very good estimate. Okay, very easy way to estimate area under the graph. So what you do is you include some of the portion from the outside, and you exclude some of the portion from the area under the graph to compensate one another, and then you can find the area of the regular shape, and that will be one easy way of finding area under the graph. So and listen, all of them are estimates. And if you get a question where you have to estimate the area, or you have to draw the tangent and find the gradient, examiner will not give one answer in the marking scheme. In the marking scheme, you will be provided with a range of answers over there. So there will be a range of answers. What do I mean when I say range of answer? Because um, for example, if I calculate gradient of this thing and I get 1.73, uh, I'm just making this number up. And when I go to the marking scheme says 1.6 to 1.9. 1.60 to 1.90. Any number between 1.60 to 1.90 is acceptable. So this means, do I get an answer which is somewhere in between 160 and 190? Then my calculation is right. And this is why the examiner asks you to estimate. Okay, there is always a factor of doubt when we estimate things. Any questions? Any queries till now?
No, sir.
Okay, just 1 second. Let me see if we can solve some questions. So let's see if we can solve this question. Some of the things we haven't done till now, so I will be doing them for you. And then when it comes to things that we have to find from the graph, I will engage you people into it as well. State Newton's first law. If there is no unbalanced force, a body. Actually, I want to say that if there's no unbalanced force, there will be no acceleration, but I have to elaborate it. If there is no unbalanced force, a body at rest remains at rest, and moving object keeps moving with uniform speed in straight line. A block of weight 15 Newton hangs by the wire from a remotely controlled aircraft. The aircraft is used to move the block only in the vertical direction. The force on the block due to the air resistance is negligible. The variation with time v of the block is shown. Okay, this is the velocity of the block. It's a velocity time graph. Determine the displacement from t equal to 0 to t equals to 3. Okay. Now, what feature of velocity time graph should give you displacement? Is it the gradient or the area? Let's see.
Area?
Good, good. So listen, this would be the negative area. There will be a negative and a positive area in this case. So there will be a negative area and then there will be, like, this is the negative area, and then there will be a positive area. And we have to find out the displacement. So what we have to find out is that how much net distance they have moved. Now what you do is you first find out this lower triangle. What will be the area of this lower triangle? What is this value? It is minus 6.8. So 1/2 into minus 6.8 into 2. So it will be minus 6.8 meters. So it travels 6.8 meters. Now, how much distance is this one? This is 3.8, 3.6, 3.4. It will be 1/2 into 3.4 into 1. So it will be 17 point.
That's 1.7.
1.7 meters. So minus 6.8 plus 1.7, we get minus 5.1. Now, the velocity is taken to be positive in the upward direction. So it means downward direction is negative, upward direction is positive. So we are having a displacement which is negative. So we say 5.1 meters, and direction of displacement is downwards. Now, how do I know it is downwards?
It's minus
Because the answer was
5.1.
yes, there was a negative sign that showed me that this is a negative sign. The change in gravitational potential energy from t equal to 0 to 3.0 seconds. If we know the mass, a weight of 15 Newton, okay, we know the mg. Answer is a change of gravitational potential energy equals to mgh. Mg is 15 and h is 5.1. So this will be
6.5.
76.5 meters. Sorry, joules. Good. Calculate the magnitude of the acceleration of the block at t equals to 2 seconds. So at t equals to 2 seconds means the gradient of the whole thing. Okay. So it is rise over run. Rise is 6.8 and run is 2. So acceleration equals to rise over run 3.4 meters. Use your answer to tension in the wire is 20 newtons. So tension equals to because tension is taking care of sorry, what happened? Okay, now I think now it is okay. Okay, I have another class waiting for me. This is end of today's lesson. We'll resume from the same point tomorrow. Thank you very much.
Okay, sir.